I'm Anna, as I mentioned. I decided 3 years ago to become a programmer. So for me, it is like an amazing journey. I am really happy to working in this world. And also, I have looked that Elixir was my first language that I learned, and I was part of this project for like 1.5 years, and recently, a year ago, my esposi and I decided to move to this wonderful city. And so far, we are so happy. We just miss a lot of Mexican food, but that's it. We are so happy for that. And yeah, currently I'm working for Derivco Sports, and also we are using Elixir as our language. So I am excited for that as well. So yeah.
Great. So about me, well, 6 years ago, I started developing a mobile application in Mexico. We're from Mexico, and since then, I was involved in developer communities and also another educational initiatives. And 3 years ago, some friend of me showed me this awesome technology, Elixir. So since then, we started to create this project. Well, the objective of this class is to show you the main problems and the main challenge that we faced building a virtual classroom. Yeah. Okay, so we can start. The company that we were working together the last year, its name is Bunsan. Bunsan actually means decentralized in Japanese, and that's because of two reasons. The first one is because we are focused on building high availability and fault-tolerant platforms and products. So we, of course, use Erlang and Elixir as our main stack. And the other reason is that all of our teammates work 100% remotely. So as many companies, you always want to improve the skills of your team. You always want to share knowledge and search for new ways to share this new knowledge, of course. So we started to question, how can we take courses if everybody is working from home? So it's really hard when you are not in the same place, in the same spot. So that was the start of our journey. And we decided to start with some courses, some webinars for our teammates. So there are too many questions that we had. So how can we track, for example, all the information regarding the course? It's really difficult because somebody could be late, and it's hard to keep on track with the flow. And how can we watch the content again? How can we share the content in a way that you can see it every time you want? And yeah, so to do that, we started to use a bunch of tools, like Zoom, Hangouts, and go to webinar or go to meeting. But the problem with these tools is that they were designed for different purpose, communication purpose in general. So you actually can use Moodle, but Moodle is just too much as EDX or another platforms. And usually, if you want to give quality content in order to have a nice course, you need to use more than one tool, to share your code, to have a tool to improve the improvisation along with the course. So actually, these tools could provide you with an environment where it could be difficult to improvise, and we will talk more about that. So next, we decided to build this platform. Tich is our virtual classroom, and we will talk about the main features of the platform.
So yeah, welcome to Tich, or welcome to Tich. This is our main platform that we built, that where you can, as instructor, you can create new courses, you can enroll students to them, and schedule the sessions that do you use for taking a new session. So yeah, this is how it looks, and the main objectives that we can achieve to build this platform were like we needed to take real-time classes, and also we want in a simple way to manage the all content regarding that course, and always be interactive with the users and students. It can be explore all the content for the course in the sessions. So talking about how we decide to build a components for us, we decide to have three main components to, as I mentioned, the real-time whiteboard. We needed the video conference to give more interactive in the course, and also the slides sharing to handle all the content that the instructors needed to give a class. So how did we build it? Yeah, guess what? Here I am in a talk about Elixir and Erlang. Yeah, maybe you know this answer. It is Elixir, of course, our main track for build it as a technology, and also because the core of the company, that Bunsan, works to love with Elixir, Erlang, and that's kind of technologies. But also we used a couple of frameworks to help us with other features that we needed. For example, for handling the conversation and the events, we used Phoenix because it is too easy to implement a new application. Also, we love Swift for get a native application in the iPad. We will see in a couple of minutes. And yeah, so speaking of Elixir and how we decide to build this, we needed a native application built in Swift to communicate through Elixir. Our main or core functionality is the web virtual classroom, that it is pure in Elixir using an umbrella application. And also we took the decision that split another Elixir application for the admin. So in the last application, we are handle the back office stuff like a subscriber for the users, logins, and yeah, to handle that. So, but it is time to talking about the good things and the bad things that we challenged building this. And yeah, let's start to talking about the whiteboard. The whiteboard, as we mentioned, we want to give the best experience for our instructors, for our users, to use Apple Pencil. For us, using the Apple Pencil was a really interesting challenge that we want to face it, because come on guys, we are programmers, so we need more challenges, and the new things that Apple made or Google made or whatever has new product, we want to spend a couple minutes to figure out how it works. So we try to achieve that also. So how can we are broadcasting all the events when an instructor or user draw something in the board or in the iPad? We send a request to the server, and the server should to broadcasting the event for all the devices that are connected, or the clients that are connected should be received that event. So how we handle this, as I mentioned, Channel Phoenix was a really helpful framework to do that, because here you can see a little of code that as we are using a WebSocket to use and handle the channels, so first you need to declare your module where define that you are using Phoenix channel for that, and after that you need two functions for that. The first one to join that channel, to subscribe that channel, and after that listen the all events that we define on event in each channel. So here you have a handling function where we name the event that we send to the channel and broadcast the event through the socket with a specific payload. So that's it. We have the channels implemented. And now we can solve that to push an event from the client and the server broadcasts that event for all the students. That's it. Quite a simple thing, but let's see in running in real time.
So yeah, the thing is that how we can draw in the iPad. Here I have the iPad with the native application. We are going to do a really quick demo. As you can see in the right upper corner, there is a broadcasting of what I am doing here in the iPad, and the back that is the Tich platform. So receiving the events. So I'm going to say hello here from the. Oh, it's going to select this one, and you can't. I think it's behind that. Let me check if I am connected. Oh, just let me. I think I'm not. Oh, I see. It's because I am not connected to the right.
To the right course. So this is where happens with channels. Using channels, you can handle different courses that corresponds for each UUID. So you be secure that the draws corresponds for the correct or right course. So you need to stay in the correct course.
Yes. So the thing is that anytime you are drawing something in the iPad, we will broadcast this event, this JSON event, and it has a path with the coordinates that you are drawing. We decided to use SVG as the standard. The standard we are using is only to declare the coordinate pairs to actually define what you want to draw. In the case of the Apple Pencil, is a little bit different because you have to define a variable width, a variable stroke width. So you have to be prepared in the front end side to handle that. Yeah. As we can see, there is an object called path object. We have the D attribute and we have the set of coordinates. Then we define an ID. So imagine you have a really long draw and you want to update it. So you need an ID to identify that stroke and then update the set of coordinates. Then we define it a simple attribute to know what color you want to broadcast and the stroke width you want to present in the case of web. Yeah. So now with that, you can draw in the platform. Great. So what would happen if somebody is late and don't catch all the content? We need a way to store all the events that come from the iPad when you draw something on where you navigate between the content. So yeah, it could be a thing if you don't know what happened in the whiteboard while you were missing the class.
So for achieve that, how can we store a lot of paths that Peter just showed us? Yeah, here's a little example that just a simple drawing in the whiteboard. In the console, you can see that all the paths or all the coordinates that we need to draw a simple example, it is a lot of. So for that, we also use Ecto as a framework, and we are storing in a database using Postgres. But at the first, this is what happens when we store just in that way to our current database. So yeah, sometimes work fine, sometimes inserts the data, and sometimes don't. So just die the database, and this is quite not a scalable thing to make things. So to solve that, we decide to integrate one more framework, or we needed to integrate RabbitMQ to solve that. So because we was thinking that many instructors can be drawing in the same time, so the server needed some help to handle a lot of inserts in the same time. So for Elixir, speaking about Elixir, it is quite simple to implement RabbitMQ. You just need add the dependency into the mix file, and that's it. You just have that, and you can integrate in Elixir using a producer that take that event and using a queue that consumer in RabbitMQ use it to process that sale. So in that process, the storage go through this RabbitMQ integration using GenServer to handle that. So in that way, we are not expecting the response for storing in the database. So with that, we go to the next level and take it more storage in the same time. So yeah, it was so great to handle that.
Great. So
And now, yeah,
we can have a restored canvas, yeah, and after that, well,
yeah, because following this strategy, we could add new actions to do that, like do, undo, or redo, or move through the canvas, and also do some zoom to get more detail for that draw.
Yeah, and now you can be an artist. I think, yeah, as you can see, we are drawing here, and you will see the results. Also, you can move between the content. I'm just going to change the color of here. So, hello from Tich. Sorry, I'm not an artist, as you can see. So also, actually, you can move here. You can navigate between the content. If I do zoom here, you can create those interaction. And the objective, of course, is that you, a student, will receive all this content in real time. So the thing is, what happens when you need more space? If you are in class and your teacher gets full the whiteboard, so he will do this. Isn't it? He will erase the whiteboard. It could be a problem if you don't ask to him that you want to take a picture or something. So the thing is that we did some tests, and it could be difficult to share multiple content. So in order to give the feature to manage all the content in the whiteboard, we thought about two possibilities. The first one was to create an infinite canvas. So whenever you move into the canvas will expand. So in a web client, we had an SVG object that was infinite. And the problem was not the web client. Actually, the problem is the implementation with mobile platforms. So our recommendation is don't do that. It could be dangerous for performance, and it will be really hard to handle all the content and to recycle all the views in order to have a good performance in memory and CPU. So we decided to do a little bit more simple version of this. We decided just go for multiple pages. So we have this simple version. You can add more pages to the whiteboard. And in order to do that, we decided to divide the events of the whiteboard into finite channels. We have one board channel that is the general events, like when the instructor creates a new page, when deletes one, or when changes the page. The objective is that the student receive this new content and to change the content. And so the page channel only will notify you when you draw in a new page. So when there is a draw from web or from iPad, all the information will pass through this channel. So as I mentioned, there is a couple of different processes to draw in the case of the web, and in the case of the iPad is kind of different. So also you have to communicate the events related with the delete and the restore of the paths, and if you drag the canvas, you have to communicate this. So how the board synchronization works, how these channels, these finite channels are complemented. So when you open the platforms, you join to the board general channel, you restore the channel, you restore all the data related with the pages in the whiteboard, so you receive all the IDs of the pages. Then you need to set up the last page that the instructor was working on. So as soon as you get that information, you will connect to this new channel. Yes, and then you will restore all the data about the channel. And when you receive a change of the page, if the ID of the change page, you will leave this channel and then you will join another new channel. And the question is why we did this. We did this to avoid client validations. If we would only had one channel in the web client, we would have to ask anytime you receive a new draw which page will present this draw. So it was a lot of ifs in the case of JavaScript. So it was not a good solution. And as you see, when you restore the grid, you get also a series of thumbnails that is a preview of the page. So it's kind of interesting how we generated these thumbnails.
Yeah, for that in Elixir, we decided to implement a main function that handles small functions that take the UUID from that page, get all the draws, convert that draws into SVG file, and convert in PNG file and resize. And the last step was to upload that file to instance to S3 to Amazon to avoid that the client looking for all the paths, and we just instead that we are just looking for a URL. That's it. So the interesting part in this is that how can we do that in a better way to don't break the system and don't wait for a response, because for that we are using a lot of resources for the server, So we decide to implement Pullboy. Pullboy, it is a dependency that you can use through the supervisors tree to add workers that do that process in a concurrency time. So the strategy was that round robin. So when gets a new process that take one. So yeah, if we go to the configuration for Elixir, we just need to add this configuration for our application in Elixir, where you can see here it is the name of the process, the name of the Gene server or the module that will attend or take that process, and how many workers you can configure to work it in the same time concurrency. And also, the next slide, I want to give you a funny story to mine, because at the beginning, as mentioned, I wasn't a programmer, so I was like an IT manager. So for me, this view is more common, because when I saw the first time Observer, I said, wait a minute, this is like an admin management for Windows or old operating systems. So please, I invite you that go to your projects, run the Observer, and you can see what is working on that, because here is our process. I just want to give some zoom in this. And you can see the observer tree as you can see the name of the process that you are working with Elixir means that you need to be sure that your process working right and your system will crash. So it is important, and I challenge you, people that looking in your projects, if everything is working in the right way.
So. And yeah, if you are working with image magic and converting images, it could be work that could take a lot of CPU actually. And then in the same way, we built a slide sharing feature. So using the same Phoenix channel, we decided to give the possibility to only upload a PDF file. So you can upload a PDF file, and you present your slides deck, and the students will receive this file, the original one. And instead you share your screen and you broadcast video, you can only have your slides deck, and you only will share these events. You will be notified when there is a new document. There is a new URL that you have to download, and then you will have notified when you need to change the page locally, and also, of course, if the instructor changed the content, if he navigates from the whiteboard and then changes to the slides, you will receive that event. So the last thing is how you can build video conference in your platforms and how we did it. Well, video conference in web platforms can be a little tricky at first, because maybe you don't know where to go, and if you are searching for support, maybe you will found this solution, WebRTC. Yeah, and WebRTC is an open source technology that allows you real-time communications in audio and video, also data in real time, but you have to keep in mind that this communication happens peer-to-peer. You will need a server just for signaling, and what signaling means. Yeah. So you have to build a signaling server in order to establish a connection between your browser. WebRTC was really innovative, because of this reason, because you don't need a man in the middle where you will pass media data, So you will follow this architecture that is called JavaScript Session Establishment Protocol. Yeah, it sounds like a big deal. Actually, WebRTC is a really big deal, but we are just wanted to give you a big picture about this. So you have a peer. You will need to share what codecs your browser will send about video and audio. All these will be encoded in a protocol called Session Description Protocol. Yeah, and your server, it could be implemented, of course, in Elixir. Actually, it is really easy to implement with Elixir and Phoenix channels and a simple Gen server. And the server only will forward, will relay this information to the other peers. But don't forget, WebRTC itself, it's only peer-to-peer. And actually, when you have a video room with beyond five people in the video room, it probably won't scale, because each time you have a new peer, you have to send a new signal, a new stream for your audio and your video, and it will be really hard to scale that. Yes, so what you will need, it will be a media server. You will need to implement a media server. A media server is actually in the middle. You keep with the same protocols, but you will have a man in the middle that will receive all these signals and will relay these signals. So you will not have performance problem in your clients. And which one you can to use? It's important first to know what is your objective. Imagine that you only want to centralize the signals. You don't want to have a pre-process of the video. Imagine your objective is to mixing all the video signals and all the audio signals in just one. If you need that, you will need an MCU, a web server that supports MCU. That means multi-point conference unit. SCView is pretty simple. It's only for relay. And Janus support this. We decided to use Janus. Janus is a WebRTC media server. You already have this technology. You only have to mount in a server in your own infrastructure. And we decided to use Janus because it's really simple, the configuration for the plugins. So if you have a feature for video room, you only need to go to your configuration files and activate the video room plugin. So that will be that. And last but not least, how you can communicate Janus with your backend in Elixir. So Janus provides a REST API where you can send requests in order to create sessions and video rooms, and you can specify how many you will support, how many peers you will support, and everything else. So our Tich client from web creates a new sessions. Then the Tich backend will communicate with the Janus media server, and the Tich clients will establish the connection with this media server. So after that, pretty much Tich was alive. We implemented all these features, as you can see, and yeah, pretty much it is ready. Great.
Yeah, we made it. So yeah, pretty much was a difficult thing to do, but we achieved that, and we are so proud for that, and we really, really enjoy to building the tomorrow classroom. Yeah. Maybe why not?
Thank you. So if you are interested in using Tich or just keeping contact with us to feedback or anything, we will be pleased about it. Here is the email. It will be great to know your comments and anything else. So if there are questions.
Thank you very much, Ana and Pedro.
Thank you.
We have plenty of time for questions.
Regarding your current setup, you've gone to go with the Apple Pencil and the iPad. Does it support people just using their finger on the iPad? And do you have future plans for implementing Android and Windows Surface solutions?
Yeah,
okay.
actually, we know that it is iPad our main feature that we implemented, but we are not close-minded that that could be with other implementation. But also, you can use your finger as well,
Yeah,
or
also.
you can use the web with your mouse and other tools. It will work as well, but the main idea, and actually the next one to build for Tich, it is the all full support for Apple Pencil.
Yeah, actually, you can draw with your finger, and you can draw in the website. Just the focus was to first establish as an ideal condition that you will have the Apple Pencil. But the thing is that we establish a series of rules in the Phoenix channels. So the virtual classroom actually is decoupled of the front end, so you can build a new front end and you will communicate with the whiteboard without any problem on any client. Yeah.
With the media server, how many students are possible to be connected in the same room? Is it
Okay.
have you done any benchmarks or anything?
Right now, yeah, it's pretty amazing because debugging Janus could be a mess actually, and we are writing documentation to deliver how you can debugging that aspect of your application. Right now, the maximum availability that we had achieving for classrooms had been like 30 people in the same video room, using only, and it is a micro instance in Amazon.
Okay.
A micro instance in Amazon is really cheap actually, our current setup, because we are only in alpha. And the main threshold more or less in the memory is like 90% of usage of the RAM, and in terms of CPU, it's so like 80% of the usage. Yeah.
Right. Thank you very much again.
Thank you.
Thank you.